Hi everyone, welcome to Science Class Physics Chapter 12 Sound Part 4. And today's topic is characteristic of sound, that is speed. That is the last characteristic you are going to learn, and reflection of sound. Before going to learn new topic, let us have some recap of previous video. You have learned 8 characteristics of sound waves. Those are oscillation, wavelength, frequency, time period. That all you learned in second video. And you have learned other than that 4 characteristics in third video. They are pitch, amplitude, loudness, timbre. Let us have some recap of it. Pitch, it is basically determined by its frequency, the quality of a sound governed by the rate of vibrations producing it. Here pitch depends on completely frequency. Higher the frequency, higher the pitch. Lower the frequency, lower the pitch. And the next characteristic was amplitude. The maximum extent of vibration or oscillation measured from the position of equilibrium is called amplitude. And the next you have learned about loudness or softness. It is determined basically by its amplitude. The amplitude of sound wave depends upon force with which an object is made to vibrate. That means loudness or softness depends on amplitude. And the last quality I have learned in the last video was timbre or a quality. It is the characteristic which enables us to distinguish one sound from another having the same pitch and loudness. And people have learned about difference between loudness and intensity. Here, intensity is nothing but amount of sound energy passing each second through unit area is called intensity. Whereas loudness is nothing but a measure of response of the ear to the sound. These are all things you have learned in the last video. Let us go for understanding what is velocity of a sound wave and how to calculate. Now let us move to a new topic, speed of sound. The speed of sound is defined as the distance which point on a wave such as a compression or rarefaction travels per unit time. We know that speed is equal to, or it is denoted as v, that is equal to distance by time. Here we mention distance as wavelength. So speed is equal to wavelength by time. And in the form of a formula, speed that is equal to v is equal to lambda by t. When you write separately 1 by t, it can be written as lambda into 1 by t. Remember again, lambda is wavelength of a sound and it is distance travelled by a sound wave in one period time. And thus velocity can be written as v is equal to lambda nu, because 1 by t is equal to nu. It is the relation between frequency and time. So from that we can write 1 by t is equal to nu, and the formula velocity v is equal to lambda into nu. And you can speak it as speed is equal to wavelength into frequency. So the speed of sound remains almost the same for all frequencies in a given medium under the same physical conditions. Children, let us understand this with a simple story. Here is a story which tells about how to calculate velocity of a sound wave. There are two friends A and B, and they are discussing in a classroom about velocity of a sound wave. So friend A asks, "Hey buddy, do you know how to find speed of sound?" And friend B says, "Of course, I know. Let me show you how to do it." They both went out of the classroom and they start finding it. Friend B says, "I will stand here and you can stand there, but we must measure distance between the two of us." And friend B repeats, "You can start the stopwatch as soon as I hit these two blocks of wood." There is a block of wood between them, and friend B says, "You have to calculate the time when he hits the block." And friend B says to friend A that, "Press the stop as soon as you hear the sound from the blocks." Now friend A was little bit confused. Friend B made him to understand, telling that We can calculate the speed of the sound by dividing the distance between us and the elapsed time. That means by using a formula, speed is equal to distance by time. Then the friend A says, yeah, is it that? And friend B says, isn't it easy? So children, it is very easy to find speed of a sound wave by using a simple basic formula, that is speed is equal to distance by time. Children, based on velocity, here I have given example 12.1 from your NCERT textbook. And the question is, a sound wave has a frequency of 2 kilohertz and wavelength 35 centimeter. How long will it take to travel 1.5 kilometer? First, you need to understand the question. Here, frequency is 2 kilohertz given and wavelength 35 centimeter is given. And asking you people how long, here the meaning of how long is time taken to travel 1.5 kilometer. Write the given first, that is frequency nu is equal to 2 kilohertz, and convert that kilohertz into hertz, that is 2000 hertz. That can be even written as 2000 per second. Next, wavelength, that is equal to lambda, and that is equal to given 35 centimeter. When you convert into meter, it will become 0.35 meters. We know that speed is equal to wavelength into frequency. And if you write in the formula, that is V is equal to lambda into nu. Substitute the values in the given things, that is lambda as 0.35 meter and nu as 2000 per second. You will get the value 700 meter per second. This is the speed of a wave. Now they are asking you people to find time. To find the time, you need to consider the distance, that is given as 1.5 kilometer. Convert that into meter. Why we need to convert is a big question. Always you need to convert given values into standard value. If the given values are in the form of a standard, you have to substitute as it is. And to find time, use the formula time is equal to d by v. Nothing but time is equal to distance by speed. The distance is 1.5 into 10,000 meter and speed is 700 meter per second. Here 0 get cancelled and remaining in numerator is 1.5 into 10, that is 15, and in the denominator it will be 7. The ratio of 15 by 7 will be equal to 2.1 second. So this is the answer, where the sound will take 2.1 second to travel 1.5 kilometers. Sonic boom, very interesting topic. This is given in your textbook in a yellow block. Of course, from yellow block, it is not the point of view of examination, but if in a simple way to make you confused, if you ask the question about the speed based, then you need to understand this. So, here is sonic boom. When the speed of any object exceeds the speed of a sound, it is said to be traveling at a supersonic speed. Bullets, jet aircraft, etc. often travel at a supersonic speeds. When a sound producing source moves with a speed higher than that of sound, it produces a shock wave in air. These shock waves carry a large amount of energy. You can observe in below figure, children. This aeroplane, however it moves, it is producing shock waves because the speed of this jet plane is more than the speed of sound wave. Here, the air pressure variation associated with this type of shock waves produces a very sharp and loud sound called sonic boom. The shock waves produced by a supersonic aircraft have enough energy to shatter glass and even damage buildings. The below two diagrams, you can observe how these aircrafts are damaging glasses as well as buildings. Children, Let us have another interesting topic, that is reflection of sound. Sound bounces off a solid or a liquid like a rubber ball bounces off a wall. Like light, sound gets reflected at the surface of a solid or liquid and follows the same laws of reflection as you have studied in earlier classes. The direction in which the sound is incident and is reflected make equal angles with the normal to the reflecting surface at the point of incidence, and the three are in the same plane. An obstacle of a large size, which may be polished or rough, is needed for the reflection of sound waves. To understand much more about it, let us do a small activity and observe how those activity helps you people to understand laws of reflection. Here is the activity to observe the laws of reflection. Take two identical pipes as shown in figure. You can make the pipes using chart paper. The length of pipes should be sufficiently long as shown. Arrange them on a table near a wall. Keep a clock near open end of one pipe and try to hear the sound of the clock through the other pipe. Children, observe the left side figure which shows how the sound wave comes and hits to the wall and comes back or bounces back in the same medium. Now adjust the position of the pipes so that you can best hear the sound of the clock. And you can measure the angle of incident and the reflection and note down the reading in the below table, where let us consider, assume angle I is 45, then when you measure angle R, that is angle of reflection, will be 45. You can observe the table where I have given 4 readings. Angle of incidence will be always equal to angle of reflection. Repeat these steps for 3 times and note down the readings as shown in the table. Just now as I discussed, angle I, if it is 50, then angle of reflection also will be 50. Of course, while doing practical, you may get 1 or 2 degree difference, but we can conclude both are equal. Now see the relationship between the angle. You will find angle I is equal to angle R. Lift the pipe on the left side of the vertical or light vertically to a small height and observe what happens. Will you be able to listen the sound? Let us discuss that. Children, if you lift the pipe or if you move the pipe or disturb the pipe, you will not be able to hear the sound. So, from this you can say the law of reflection. The law says angle of incident is equal to angle of reflection, and incident ray, normal ray and reflected ray all lie in a same plane. You can observe below figure, children, where angle of incidence is shown, angle of reflection is shown, and angle between both is shown with blue color as an incident wave, whereas a reflected wave with a red color. And left side figure is showing sound waves, how it comes and hits to a absorbed sound material, as well as to that material after hitting, how it comes out with the less amount of sound waves. Observe carefully, children, and enjoy the video. Here ends the video, children. You have learned in this video how to calculate the speed of sound wave and about a sonic boom, and next reflection of sound and loss of reflection. Now let us move to the worksheet. Observe the worksheet, solve the worksheet and write and keep it preserved. Submit after reopen. Worksheet 4. First question, define speed of sound waves. Second one, how are the wavelength and frequency of a sound wave related to its speed? In this question, you must write about how to write a formula or a derivation of formula. And the third one, write the laws of reflection. Fourth one, a simple numerical is given, children, that is, calculate the wavelength of a sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. Enjoy the day, children. All the best.